Good day, viewers. I remember myself again, Otemu Ogenenyero, teaching on YouTube. I encourage you to subscribe to my YouTube channel at Otemu Mass Success. I'll talk about the maximum and minimum points. Let's talk about the maximum and minimum point. Before we can talk about maximum, now when the second derivative is less than 0, it is maximum point. Then when the second derivative of x is greater than 0, it is minimum. Then when the second derivative is equal to 0, it's called saddle point. So you can say d square y over dx square. Instead of this, you can also use that to write. If it is less than 0, it's maximum. If it is greater than 0, it's minimum point. So let's solve this expression. Determine the minimum point of y is equal to 2x raised to the power 3 plus 3x raised to the power 2 minus 3x plus 36. So let's find the first derivative. dy over dx, or you can say the function of x, can write it like this too, and you want to write, is equals to 3 times 2 is 6, then 3 minus 1 is 2, which is 6x raised to the power 2, plus 2 times 3 is 6. 2 minus 1 is 1. So yes, 1, don't write it. Then 1 times 36 is 36. 1 minus 1 is 0. X raised to the power 0 is 1. 1 times 36 is 36. When you are differentiating a constant, you have 0. So let us now equate the first derivative to what? To 0. When that write 6x squared plus 6x minus 36 is equal to 0. Okay, let us reduce first. I want to reduce the expression. Divide through by 6, because 6 can go through. This will cancel this. You are left with x squared. This will cancel this. You have plus x. This will cancel this. You have 6 is equal to 0. So now, after I've done that, we now solve quadratically. We solve quadratically. Now, what are the roots of this expression? Now, I'll write x squared here. I'll write x bracket. We are factorizing in our head. I've taught you in my previous topic how to factorize. Now, the two numbers you multiply, that will give you minus 6. When you add the 3 plus 1 is plus 3 and minus 2. Look at it. Plus 3 times minus 2 give us minus 6. Plus 3 minus 2 give us plus 1. Plus 1x. So that are the roots. So we'll now equate the root to each of the bracket to 0. So x plus 3 is equal to 0, or x minus 2 is equal to 0. So x here, this one will become minus 3, or this one will become plus 2. So this is the root of the equation. And we can call that the critical point also. Now, let us now find the second derivative, d squared y over dx squared from the first derivative. When you derive here, this time this gives us 12x. Then 2 minus 1 is 1. So I'll now say plus 6 times 1 is 1, and 1 minus 1 is 0. So that one is 6. So when we differentiate this, we have 12x plus 6. Now, we now say, okay, we want to put it down when the value of x, what is the value of x here? Okay, look at the value of, when the value of x is equal to minus 3. So we put it into this expression. So d square y over dx square is equal to 12 bracket minus 3 plus 6. Now, this will give us minus 36 plus 6. That will give us minus 36 plus 6. What is minus 36 is equal to minus 30. So since d square y over dx square is now less than 0, comma, it is minimum, it is maximum point. Since d square y over dx square is less than 0, is maximum point. So let's do the other root. Let's put the other root. Say when x is equals to 2. So d square y over dx square is equal to 12x plus 6. So when x is 2, it will be 12 into 2 plus 6. So here give us 24 plus 6 is equals to 30. We now write, so since d square y over dx square is greater than 0, comma, it is minimum point. So this is how we can solve problem on maximum point and on minimum point.